All right, continuing on with our transformations of our functions. This is section 1.2. What happens when the coefficient of the x term is negative? So again, with your graphing calculators, I want you to graph the parent function of a quadratic, f of x equals x squared. And then I want you to graph f of x equals negative x squared. Actually, the way I would rather look at this is the opposite of x squared. And you'll see when you do that graph that it changes the orientation of the parabola. Now, all of a sudden, that parabola is pointing downward. What happens when there's more than one transformation, which there will be in a lot of our functions that we do. So let's look at the parent function of a quadratic again, f of x equals x squared. So if you graph this one, you'll see that it's going to be a shift to the left of 2 units. And then if you add this part, that's going to be down 3 units. So if you have a problem, let's say you have a problem with this function right here, and you have to describe the transformation of this from this, you would just say, this is how I would do it because it's easier, to the left 2, and then down 3. You could write that out all out in words if you choose to, but I'm kind of lazy and I just like to do that. Alright, so now we're going to talk about horizontal shrinking and stretching versus vertical. And if you'll recall back in section 1, we talked about vertical stretches and shrinks. That's when that parabola got real skinny and then it got real fat. Okay. I'm going to warn you right now that this part gets kind of confusing. Just know that the more we go over it, the easier it'll be for you to understand. Just make sure you take really good notes here. Just copy what I've got written down here for you. Okay, in a horizontal stretch or shrink, the inputs are multiplied by a number other than 1. If you'll recall, in a vertical stretch or shrink, it was the outputs that were multiplied by a number. So now we're talking about what if only the inputs, the x values, were changed. So the graph of y equals f of a times x is a horizontal stretch or shrink by a factor of 1 over a. I want you to notice this connection here, because this is a big difference from the vertical stretch or shrink. If it's vertical and the multiplier is a, then the factor of transformation is also a. If it's a horizontal, because remember only the inputs are being affected, the factor would actually be 1 over a. We're going to do some examples that hopefully will make this a little more clear, because right now it's probably clear as mud to you. So, a horizontal stretch moves the graph horizontally away from the y-axis, and x is going to be between 0 and 1 on a horizontal stretch. A horizontal shrink moves the graph horizontally towards the y-axis where a is greater than 1. Again, clear as mud, right? So what's the difference between a horizontal and a vertical stretch or shrink? Remember that the vertical stretch or shrink multiplies the output. So it would be y equals some constant times the whole function. That's a vertical stretch if a is greater than 1. It's a vertical shrink if a is between 0 and 1. A horizontal stretch or shrink multiplies the input. So in other words, it looks like y equals f of a times x. This is the biggest difference right here. You want to see the connection there. So this is going to be a horizontal stretch or shrink by a factor of the reciprocal of this, 1 over that. All right? Let's do an example where it's telling us to actually make a change to a function. All right, so let's say we have a function f of x equals the absolute value of x minus 3 minus 5. And the first problem that we want to do, we want to write a function, g, whose graph is a horizontal shrink of the graph of f. And don't forget that this is f, by a factor of 1/3. And the second problem, we're going to write a function h, whose graph is a vertical stretch of the graph of f by a factor of 2. Let's work on a first. So a horizontal shrink by a factor of 1/3, remember that's the a value, multiplies each input value by 1 over a, which would be 3. So g of x is equal to f of 3 of x. So that means wherever there's a x in f, we're going to multiply it by 3. So remember, here, let's write f of x is equal to the absolute value of x minus 3 minus 5. So this is telling me that I'm only multiplying x by 3. Well, if I do that, I'm going to get the absolute value of 3x minus 3. This doesn't change, because all I'm doing is replacing this x with this factor. Okay? Now, let's do the second part of that problem, part B. A vertical stretch by a factor of 2, which is a, multiplies each output by 2. So what that means, that g of x is actually going to equal 2 times the entire function of f of x. So this in parentheses is f of x, and I'm multiplying the whole thing by 2. So using the distributive property, you're going to get 2 times this and 2 times this. And our answer would be 2 times the quantity, or the absolute value of x minus 3 minus 10. Phew. So, I'm not going to lie, the difference between vertical stretches and shrink and horizontal stretches and shrink is very, very confusing and sometimes hard to grasp the first time you see this. We're going to go over it many, many times. If you want some more demonstrations, you could probably Google horizontal versus vertical stretch and get a whole bunch of hits on YouTube. You could also go to khanacademy.com. You do not have to be part of a class to use Khan Academy. You could just put what I just said in the search bar on Khan Academy, and they're going to have articles or videos for you to watch. Just know that everybody kind of struggles with that concept at first, and we'll get through it the more we do it. All right, see ya.